All right, this is grade 6, unit 2, lesson 4. And in this lesson, we're going to continue experimenting with equivalent ratios. In our previous lesson, students learned how to double a recipe for making drinks or food, and then in this lesson, we're going to continue doing that same kind of physical experimentation, only this time we're going to be talking about paint and recipes for creating colors and doubling the recipe or tripling the recipe in order to maintain that same color. So let's get started. All right, we're going to begin with a number talk. And in this number talk, they kind of give you some sort of suggestion as to what they're aiming for in this number talk, but really we want to allow students to use their logic in order to express how they're going to find each of these values, each of these products mentally. And the idea would be start with that 6 times 15. And really this is kind of like a number string. So we could say, well, if we start with that 6 times 15 and using some sort of number sense, we derive that that answer is 90. Now, how might we do that? Well, we might recognize that 15 is really a 10 and a 5. So we might do 10 times 6 and then 5 times 6, add those together. So 60 plus 30 gives us 90. So that's going to get us started, right? Now, the idea is, what are we going to do to get our answer to 12 times 15? Well, the idea would be maybe if we recognize that 6 copies of 15 is 90, then 12 copies of 15 is going to be twice as big because we go from 6 to 12, and that's doubling, so our new answer here is going to be 180. All right. And then similarly, what is 6 times 45? Well, we know that if 6 times 15 is 90, and we recognize that 15 multiplied by 3 gives us 45. So that means we know that our answer is going to be 3 times as big as 90. So 90 times 3, triple 90, because we've tripled the 15, gives us 270. And then lastly, the idea is, well, what might we do to get 13 times 45? Well, we know 6 times 45, so we can get 12 times 45 simply by doubling, and then we have to add in an additional 45. There's a variety of ways of how we can use these 3 previous numbers, answers, to get this one. I'm going to leave you that to struggle with. But parents and teachers, really the point of this number talk is to get students thinking flexibly about, in this case, multiplication, but specifically just getting number sense, developing that number sense. All right, so let's keep going. So now there's this wonderful Geogebra applet created by my friend Jen Silverman. Go online and click it and do it. It's really kind of fun. It basically you have 2 flasks or 2 beakers, one on the left, one on the right, and you got a couple of buttons. You got a button that inserts blue water, then you've got another button that inserts yellow water, and you're mixing them together, and it's really a neat applet. We're going to go old school with just kind of paper and pencil, but if we have this original ratio of 5 to 15, so 5 is the blue, and 15 is the yellow. All right, so that might look like, let's see, it might look like this. So 5 to 15. All right, and so we're going to say this is the blue, and I'm going to zoom in a little bit here so we can see it. So this is the blue, and this is the yellow, 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 and each of these are a 5, let's say. So really, what I should do is I should label these 5, 5, 5, and 5, and then call this the blue, and then call this the yellow. All right, so as I'm thinking about this recipe, there's my original 5 to 15 ratio of blue to yellow. Now, if we're supposed to double this recipe, what is this going to look like? Well, it just means we have to add another unit of blue, which is really 5, and then we add 3 more units of 15, and that gives us another amount of the same. So I'm going to zoom, I'm not going to zoom in. I'm going to just give that another blue and then another yellow. And remember, that's 5, and then this is 5, and this is 5, and this is 5. So we have one copy of 5 to 15 right here, and then we have a second copy of 5 to 15 right here. So we know that that's going to give us the exact same shade of water, that it's going to kind of be a green water. If you mix blue and yellow, you're going to get green. Because we know that 5 to 15 and then 10 to 30 is going to give us the same. How did I get, where did the 10 come from? The 10 came from the fact that I have 2 units of blue, and each unit is 5, and then I have 6 units of yellow, and each unit is 5. Now, where did I get the number 5 from? Well, I don't know, I just kind of saw this 5 to 15 up here, and I saw that 5 is that kind of common factor, so I just kind of instantly modeled that ratio of 5 to 15 is by just doing 5 and then 1, 2, 3, and there's my 15. I just kind of saw it that way. And remember, these are the blue and these are the yellow. So moving on, as we keep going, I'm scrolling down. Eventually I'm going to get there. All right. So what we're supposed to do now is we're supposed to get into that physical experience here. We're going to actually label some cups. We might actually have food coloring, and we're going to do it, and that's all this sort of stuff. And is the ratio the same? And of course, so that parents and teachers, this is really valuable stuff. But if you don't want to go playing with the actual food colors, go ahead and go to that Geogebra applet. It is a wonderful applet and totally worth your time. All right, so if we want to triple the original recipe, what would it look like? Well, let's remember that original recipe looked like this. We had 5 units of blue, and we had 15 units of yellow. So that's the original. So if we're going to triple it, what would it look like? Well, we're going to have 3 of these blocks for blue, and then we're going to have 3 times as many yellows. So we're going to end up with 9 units of yellow. So we're going to have 3 units of blue because we want to triple. So we want to triple this times 3, and we want to triple this times 3. So let's do that. Let's draw it. It's going to go over here. So 5, 5, 5 for the blue. And goodness, we're going to triple this, which means we're going to have 9. And inside each of those represents 5, I think it was milliliters. And that's the yellow. And that's the yellow. So this is what our recipe would look like if we tripled it. We would end up with, specifically, we would end up with 15 milliliters, I think it was, 15 milliliters of blue, and we would end up with 45 milliliters of yellow. Don't go quoting me if in case I'm wrong on the milliliters. In fact, I'm kind of dying to know. So let's go up there and look. Let's go all the way up. There it is. And yes, indeed, it is milliliters right here. We were talking about milliliters, so I remember that correctly. Yay! I love it when I remember it correctly. So let's zoom. Here we go. And let's keep going. So again, we've got this more of this physical experience here. So this is just do the cup, mix it up with the food coloring, see what happens. That's really kind of cool stuff. But again, you can continue using the Geogebra applet if you wish. All right. Number 3, invent your own recipe. Woohoo! Invent your own recipe for a bluer shade of green water. All right, so now remember, if our original was 5 to 15, our original, whoa, I don't want that one. I want this one, 5 to 15. where that 5 was the blue and the 15 was the yellow. So if we want something bluer, it means we need to increase this 5 to anything we want. So let's bump it up to, I don't know, 10. Let's bump it up to 10 or 6. It doesn't really matter. Let's bump it up to 9 just to be different. So draw a diagram to represent what you would do. So it would be 9 to 15. So our ratio would be 9 blue to 15 yellow. All right. So I'm going to make it simple. I'm just going to put a single box and call it 9, and then a bigger box and call it 15, and that's what it would look like. Now, parents and teachers, you may want to be a little bit more precise. So you can even go this direction and go horizontal and say 1, 2, 3, 4, 5, 6, 7, 8, 9 blues, and then do the same thing for yellows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, in which case now each of these blocks represents 1 milliliter. All right, we could have done it in a variety of ways. A couple of different options right here. I think they're both equally valid, I suppose. So find the final cup. Label the final empty cup with a ratio of blue water to yellow. So we would actually test this out in the physical. Right now that we've modeled it, we're going to have 9 milliliters of blue, 15 milliliters of yellow. We're going to mix it. We're going to look at it, and sure enough, is it a bluer shade of green? And we're supposed to say, yeah, it is, because we did it right. All right, now we're going to skip that. Are you ready for more? And we're going to go straight here to the perfect purple water. The recipe for perfect purple water says mix, and here's the key right here. Mix 8 milliliters of blue water with 3 milliliters of red water, and that's going to give us this nice purple. And then it says Jada mixes 24 milliliters of blue and 9 milliliters of red. Andre mixes 16 and 9. So that's the setup right here. Now we're going to scroll down to the next page. Which person will get a color mixture that is the same shade as the perfect purple water? So we're going to go back up here, and we're going to take a look. Now the perfect purple says it's supposed to be 8 blues and 3 reds. All right, so if we do that, so the perfect purple is going to be, and I'm going to do it right here. Okay, so blue and red, and we're supposed to have a ratio of 8 to 3. There it is, 8 to 3. Now, Jada mixes 24 milliliters of blue with 9 milliliters of red. So if we look at Jada, and I'll put Jada down here, Jada, her ratio is going to be 24 blue and 9 red. And then Andre, A-N-D-R-E, Andre is doing 16 blue and 9 red. Well, we know they can't both be right because they both use the number 9. So if one of them is right, then the other person can't be right because they both use 9 milliliters of red, but one uses 16 of blue, milliliters of blue, and Jada uses 24 milliliters of blue. So they both cannot be right. So let's take a look. Well, if we think about this and we say, all right, Jada, she took the 8, the original 8, and it looks like she tripled it to get 24, and then she took the original 3 of red, and she also tripled it to get 9. So it looks like Jada and I'm going to put a little time sign here, time sign and time sign. So it looks like she perfectly tripled the recipe. She took the original recipe, which was 8 to 3. She tripled the 8 to get 24. She tripled the 3 to get 9. So Jada looks like hers is going to be the exact same as the perfect purple. But let's take a look at Andre just to be sure. So Andre, when we look at Andre, he took that original 8 and he doubled it. That's how he got the 16. But then he took that 3 of the red, he turned it into a 9 by tripling the 9. So that's no longer the same recipe, because while he doubled the blue to get 16, he tripled the red to get 9. So therefore his recipe is going to be different than Jada's. Jada's recipe is going to be identical to the original perfect purple recipe. So let's scroll down here. So which color is the same? We just answered it. It is Jada. All right. Now find another combination of blue and red water that will also result in the same shade. So remember, if the original was blue and red, it was 8 blue and 3 red. So if we want a different combination, so we could quadruple the recipe. So we can times it by 4. So we can times that by 4 and times the red by 4. And that would give us a combination, a recipe, blue and red. That would give us 32 units of blue and 12 units of red. So we've quadrupled the recipe. So the idea is I took the 8 times by 4, that gave me 32. I took the 3 times by 4, and that gave me 12. And that's how we know it's going to give us the exact shade of perfect purple water as the original. And that wraps up the summary, the lesson itself, the idea of when you have an original recipe right here, if you double it or if you triple that exact recipe, then your new ratio is going to be the exact same as the original. It's equivalent to the original, and it's going to result in the same recipe, the same shade of color in this case. All right, so now it's time to practice. We're just going to do our classic practice. So it says, here is a diagram showing a mixture of red paint and green paint needed for one batch of a particular shade of brown. Add to the diagram so it shows 3 batches. So we want 3 batches of the same shade of brown paint. Well, that's easy enough. So we're going to do another batch right here, and then we're going to add a 3rd batch right here. And that's how we know that this original ratio, which is 3 to 2, is equal to 9 to 6, because we just took the original ratio and we tripled it, and now we have 9 reds and we have 6 greens. Beautiful. All right, Diego makes green paint by mixing, by mixing 10 tablespoons of yellow paint and 2 tablespoons of blue paint. Which of these mixtures produce the same shade? So that 5 to 2 is the important thing. 5 yellows, 2 blues. So 5 yellows, 2 blues. So I'm going to write that down somewhere. Where can I write that in a nice, pithy way? So we could say yellow to blue is equal to 10 to 2. All right, there's my ratio. Now it says for every 5 yellows of blue, you get 1 tablespoon of yellow, and that's the exact opposite. It's really this original ratio right here would be the same as if we cut it in half. If we cut that recipe in half, we would end up with 5 to 1, but that would be the yellow would be 5, and the blue would be 1. So that is a false statement. So I'm going to put big old F right there. Mix tablespoons of blue and yellow in the ratio of 1 to 5. Blue to yellow is 1 to 5, and we can see blue to yellow is 1 to 5. So that is a true statement right there. That B is a true statement. Now we're on C. Mix tablespoons of yellow and blue in the ratio of 15 to 3. So yellow to blue, that's the order they gave it to us, yellow to blue, in the ratio of 15 to 3. Yeah, it looks like if we took this simplified ratio right here and tripled it, you'd get 15 to 3, and so C is correct. So that's a true statement. And lastly, D, mix 11 tablespoons of yellow and 3 tablespoons of blue. Well, our previous answer was true. That's 15 to 3, so there's no way that a 11 to 3 could be the same shade as 15 to 3, so we automatically know that that one's false, and there you go. All right, number 3. To make one batch of sky blue paint, Claire mixes, and here's the key. We always got to look for that ratio. 2 blues, 2 cups of blue, and 1 gallon of white. So our ratio is of blue to white, and just using numbers, just naked old numbers, is 2 to 1. Now that 2 happens to represent 2 cups, and this 1 happens to represent 1 gallon. So let's kind of pay attention to that. So it says, explain how Claire can make 2 batches. Well, she's just going to double each of these. So she's going to end up with 4 to 2. But remember that 4 represents 4 cups, and that 2 represents 2 gallons. Explain how to make a mixture that is darker of blue, a darker shade of blue. Well, all she has to do is take the blue and bump it up to any number she wants. Technically, I suppose she could also take the white paint and reduce it, but I think a more obvious way to think about it is to take that blue and bump up that number. So all she has to do is change that 4 to a 5 or a 6, and technically that would make it a bluer, darker shade of blue. And then similarly, explain how to make the mixture, a lighter shade of blue. Well, all you have to do is take your blue and reduce it by a number. Like take that 4 and turn it into a 3, keeping the white the same. Very good. All right, we got a couple of questions here, and it's crossed over by the page here, so we're going to ignore all this junk here. Okay, it says a smoothie recipe calls for 3 cups of milk, 2 frozen bananas, and 1 tablespoon of chocolate syrup. There is your ratio. So if we want to create a diagram for that, I could do, let's say, I'll do it down here. M for milk, and it says 3 cups of milk, 1, 2, 3, and then B for bananas, and it says 2 frozen bananas, so I'll do 2. And then chocolate syrup, I'll just put a C for chocolate syrup, and it says 1 tablespoon. So there is my diagram. Where am I? There is my diagram right here. Woohoo! Okay, so now the next question, it says down here, write 3 different sentences that use a ratio to describe this recipe. So we're talking about like the ratio of milk to bananas is 3 to 2, or the ratio of chocolate syrup to the cups of milk would be 1 to 3. There's a whole host of different sentences that we could use. We could also double the recipe and change it to 6 to 4 to 2 if we double that. So there's a whole host of things. Parents and teachers, the point of this is to get students thinking flexibly about these ratios that they're learning. Now we're going to do a little bit of review, write the missing number under each tick mark. All right, so here we go. I don't know. That looks like that's going to be a 3. So it looks like we're going up by 3. So 3, 6, 9, 12, 15, 18. How did I get that? I don't know. I just kind of looked and saw that this was skipping 2 intervals, 1, 2, and I knew I needed to increase it by 6 over those 2 intervals, so that's why I decided each tick mark must have been 3 higher than the previous. And then find the area of the parallelogram. Show your reasoning. So remember, the area is the number of squares inside that figure. We remember that there is a formula for the area of a parallelogram, that the area of a parallelogram is base times height. And in this case, the base is going to be right here. It's 3. The height in this case is going to be, I don't know, whatever this is, 1, 2, 3, 4, 5, 6, 7. The height is 7, and so 3 times 7. 3 times 7 gives us 21 square units. All right. Remember, we could have like taken, well, yeah, I'm happy there. Let's let's leave that. And then. Well, yeah, we're going to leave that. Okay, good. And number 7, I think this is the last one. Complete each equation with a number that makes it true. All right, so a little bit of review. This one's going to be 11/4. This one's going to be 7/4 because, remember, 11 copies of a fourth means you have 11/4. This means you have 7 copies of a fourth, which means you have 7/4. Similarly, this is 13/27. Don't let the numbers freak you out. This says we have 13 copies of 1/27. So there is our answer, 13/27. Similarly, way over here, 13 copies of 1/99. That's easy. That's just means you have 13/99. And then last one, this means X copies of wyths, 1 wyth. And so that is X over Y, because that's every single example followed that same pattern. So this is going to be no different. All right, that wraps up Grade 6, Unit 2, Lesson 4. Students were experimenting with equivalent ratios by mixing colors together in order to maintain that same hue or that same color, like paint at a hardware store or something. So I hope you had fun. If you need more support, in my little thing down there, the little description box, go ahead and email me, and I'm happy to help.